So the final thing we did was we got really interested in this question of flexibility. One of the most important tests for kids was the idea that when they are tested with something completely new, they had never seen a gesture or some kind of communicative information before, could they solve the problem? And the answer was yes. If you took, for instance, this block and you saw Fifi in the last lecture, the chimpanzee, try to solve this exact problem. If you take just a block, and a child has never seen you place a block on a cup before and use that as a gesture to indicate where they should search for something, I've never done that with my child. I don't think many people have done that either. And when you did that with kids, because they're using communicative intention, because they are sitting there trying to say, what is he trying to tell me while he's helping me? Can I interpret those cues, trying to figure out what he's saying? They were able to immediately on their first trial use a novel marker where you take a block and put it on the cup where the food is. Well, that's what we found in dogs, is that when you put a novel marker on the cup where the food is, dogs immediately spontaneously were able to do this, whereas chimpanzees were not very good at it. So I'll show you a video of that in just a second. But the reason that was really important was it showed that dogs using gestures, it isn't just that they slowly learn certain behaviors that they've seen before over a long lifetime. They're generalizing it to new situations. The other thing that people have done is they've pointed to dogs with their foot. And that's one of the things that you'll do if you decide to do Dognition, is you can point to one of the two cups with your foot. That's something that most dog owners don't do, but it's been shown in lots of studies that dogs are really good at even using gestures they've never seen before, like pointing with your foot, or in this case, using a marker. That was then what got us to realize, wow, dogs are doing something really special here. This is a level of flexibility we've only seen in human children. We really haven't seen in other animals. So here's a video of Fifi again. You remember Fifi trying to find the grape here as it disappears under the cup on the left. And then I'm going to put a block on top, and you see her look at it, but she still chooses the other cup and then scratches her head in frustration. And for any chimpanzee lover out here, this is a horrific video to watch, because this goofy mutt, who is adorable, is going to solve that same problem without any trouble at all. And again, having never seen this before, there's the block. The dog says, why don't you just hand it to me? Of course I know it's there. And importantly, we did all sorts of controls, because this is an experimental manipulation, and we looked at whether they were using olfaction. They weren't in this context. The other thing we did is we actually would put the marker on the cup, and there was nobody, the dog wasn't present. And then we brought the dog back in, but when they came back, there was no person, so there was just a cup with a block on it, and they did not use the marker in that context. And we also removed the motion. We did a control where they couldn't see you actually place the block, but there was a person there, and they did use the marker. So that's really important, because it shows that they're not just attracted to the marker. It's not like they just thought that was an interesting toy and that they would go to it anyway. They had to really see somebody touch it, hold it, but they didn't have to see the motion. So as soon as a human touched it, it became really relevant as something that was potentially communicative. So here's the data. This was the direct quantitative comparison of dogs to chimpanzees, and you see that dogs really did a lot better than chimpanzees. And in fact, when we looked at individual dogs, almost all of them passed as individuals using this novel marker, and almost none of the chimpanzees did. So this really was a big surprise, because most people think because great apes are close relatives, they must be smarter than other animals. But if you take a cognitive approach, an ecological approach, you're open to this type of discovery that distantly related species could be more closely similar in different traits if their ecology has shaped them in the same way. So Mike and I wrote a paper after we did a whole series of studies like this. And remember, Mike Tomasello had thought that dogs would not show these skills. And so this was really exciting. And again, just goes to show you how science really works. He was excited to find this and be involved in the discovery. And he even, wrote an important paper with me about how dogs may have human-like social skills, even though they're so distantly related. So this was where we really started to understand what makes dogs remarkable. Remember, I set up the puzzle of how did dogs happen? what is the genius that allows them to have more jobs than ever and go across the whole world with humans and be on every continent where we are. And we were really excited in making this discovery because the thing that we think is so important, making young children able to understand communicative intentions and then participate in human culture and eventually learn language, is in dogs. While, chimpanzees and bonobos don't seem to show the same skills. Now that was exciting. So to summarize, dogs use human gestures such as pointing to find food. Now you know that, but again, that's the exciting thing is when you start comparing dogs to other species and even to ourselves, you realize that that's really remarkable in terms of the level of flexibility. They're not using olfaction in this game to find food, which is a surprise to many, but that's something that's replicated many times. And an important thing in science is that not just I found the phenomenon I'm describing, but lots of other people have found the same thing. So that means it's probably really real. Dogs are not just simply responding to the motion created by the gesture, so it seems like it's more than just some simple low-level explanation. We can rule out, the parsimonious explanations, and Morgan would be happy with us because we talked about Morgan's canon. And then dogs may actually, as a result, be reading communicative intentions of humans. This still remains a really active area of research to really nail down what dogs are doing, but this first set of studies definitely suggested they were doing something really interesting that other animals had not been observed to do before. And I think the biggest surprise, of course, for a lot of people is that dogs are remarkable using gestures compared to apes. And that, of course, was what then caught a lot of people's attention and drove a lot of this revolution. It's very important for me to say that when we discovered this, it was also discovered independently and published by a group in Hungary led by Adam McCloskey. They found the exact same thing, that when they did the study and published it the same year that we did, that dogs are really good at using gestures and all of the same things that I summarize here. And that was also really exciting because it was, wow, somebody on the other side of the world we hadn't even talked to did the same study and found the same thing. Maybe we're really onto something real here. What we're going to talk about in the next lecture is if dogs really are remarkable for these understanding our communicative intentions, where did it come from, and what's the origin of these abilities?